Have you ever stopped to think about what's actually happening, like behind the scenes when you use a website or an app?
Right, like that simple calculator or even, those complex web applications we use every day.
Exactly. Every single interaction, every calculation, it all relies on these fundamental building blocks. And today, we're taking a deep dive into those.
That's the plan. We're focusing on JavaScript operators. Think of JavaScript as the language, right?
hmm
Well, operators are the verbs. They're the action words telling the computer what to do with the data.
And for this deep dive, we're drawing from a pretty comprehensive guide, JavaScript Operators, Complete Developer's Guide. But we're not just reading it aloud, obviously.
No, definitely not. We've pulled out the really important bits, the surprising insights, and those distinctions that, honestly, even experienced developers can sometimes gloss over.
Because getting these right is just, well, it's crucial, isn't it?
Uh,
Whether you're just starting or you've been coding for ages.
Absolutely. It's the computational backbone. Understanding the nuances here is a shortcut to writing code that's, efficient, readable, maintainable. It's about really getting how JavaScript works.
Okay, so let's unpack that. We call them verbs, but what are JavaScript operators, technically speaking?
Okay, so basically, they're special symbols, sometimes keywords, that perform operations on values or variables, what we call operands.
Operands, got it.
They let you manipulate data, make decisions, control how your program flows. They really bring the code to life.
Right, they make stuff happen. So where do we start with all these action verbs?
Let's start with the most familiar group, arithmetic operators. These are all about math calculations.
The classics. You've got plus for adding, for subtracting, for multiplying, for dividing.
And don't forget percent for modulus that gives you the remainder after division. And for exponents, raising to the power of something.
And the plus sign is a bit special, isn't it? It does double duty.
It really does. It adds numbers, obviously, but it also joins strings together, concatenation. Same symbol, two different jobs depending on the data. It's a classic JavaScript quirk.
Yeah, that one catches people out.
Definitely. And besides those basic ones, you also have the unary operators, things like plus plus to increment a value by 1 and to decrement by 1.
Okay, let's make that concrete. The guide had a good example, calculating a price.
Oh, yes, the price calculation.
So like let price you will 100,
Yeah.
then let discount 20,
Right.
then let final price discount. That uses the subtraction operator, so final price is 80.
Makes sense.
Then you calculate tax.
Right.
Let tax final price 0.1. Multiplication gives you 8 for the tax. And finally, let total final price plus tax. Addition brings you to 88. See? Operators doing all the work.
Precisely. A clear chain of operations. And once you have these results, you need to store them or update them efficiently. That leads us straight into assignment operators.
Right. These are about managing variable values smoothly. The basic one is just the simple assignment.
Yeah. X equals 5. Straightforward.
But then you have the compound ones, plus, row many, per parity. These are super useful.
You really are. The main advantage is just how concise they make your code. Instead of writing, say, score is score plus 50.
You just write score plus 50.
Much
It's shorter.
Exactly. The guide showed it well. Let score 100, then score plus 50 makes it 150.
Okay.
Then score it 2, bumps it to 300,
Right.
and score equals 3, brings it back down to 100.
Right.
It's just cleaner, more readable, especially when things get complicated.
Totally agree. So we've covered manipulating data, assigning it. What about making decisions based on that data? That sounds like comparison operators.
You got it. Comparison operators look at the relationship between two values. And the key thing here, the absolute takeaway, is they always give you back a Boolean.
True or false. That's it.
Yep. Which is fundamental for any kind of if statement or conditional logic.
And right away, we hit a big one, a really crucial distinction
Oh, well.
versus loose equality versus strict equality. This trips people up constantly, right?
Oh, constantly. This is probably one of the most common sources of subtle bugs in JavaScript.
Okay, so break it down. What's the actual difference? Use an example.
Sure. Let's say you have let user age equals 25, the number 25. Now, if you use loose equality, like console.log, user age equals 25. Notice the quotes. 25 is a string.
Right.
That will actually log true because it tries to be helpful. It performs type coercion. It converts the string 25 to the number 25 before comparing.
Ah, okay, so it's like close enough.
Kind of, yeah.
Yeah.
But that helpful behavior can cause real headaches. Now, contrast that with strict equality.
Triple equal.
Triple equals. If you do console.log, user age equals 25, that log's false because it checks both the value and the type. No coercion. Number 25 is not the same type as string 25, so it's false. Full stop.
That seems much safer, like less guesswork.
Infinitely safer. I remember debugging this weird issue once. Turned out a labels was letting 0 be considered equal to an empty string, which had security implications. Nightmare. Using the rule prevents that whole class of problems.
Right. Wow. Okay, so the golden rule is definitely lean towards hers.
Absolutely. Use strict equality unless you have a very, very specific reason not to, which is rare.
And the same logic applies to inequality.
Resumptive.
For loose, pounds for strict.
Exactly the same principle. Where is your friend?
Got it. And then you have the standard relational ones too, right? Like greater than, less than.
Yep. For greater than, less than, greater than or equal, less than or equal. So our age example, let user age 25, let minimage equal 18. Console.log, user age minimage, that's clearly true. Straightforward comparison.
Okay, that makes sense. So moving from individual comparisons to combining conditions.
Yeah.
We get to logical operators.
Right. These work with Boolean values, true or false, to build more complex decision-making logic.
And the main ones are AND, AND, or SER.
Those are the big three. An logical AND only gives you true if both sides are true.
Okay.
Logical OR gives you true if at least one side is true.
Makes sense.
And logical NOT just flips the value. True becomes false, false becomes true.
So, quick example. If is logged in is true, but has permission is false.
Then is logged in and has permission would be false, because both aren't true.
Right. But is logged in has permission would be.
That would be true, because at least one of them, is logged in, is true.
And has permission would also be true, because it flips the original false.
Exactly. Now, a really important concept with the AND is something called short-circuit evaluation.
Short-circuiting, what's that about?
It's actually pretty clever. With NND, if the first part is false, or falsy, like 0, null, JavaScript doesn't even bother looking at the second part.
Because it already knows the whole thing has to be false.
Precisely. Why do extra work? And similarly with ANR, if the first part is true, or truthy, it doesn't check the second part either.
Because it already knows the whole thing must be true.
Exactly. This isn't just an optimization, though. Developers use it deliberately.
How so? Like beyond just skipping a function call.
Oh, yeah. It's super common for setting default values instead of a clunky if statement.
You could do something like let user setting save setting default.
Perfect example. If save setting exists and isn't falsy, it uses that. If save setting is null or undefined or 0 or, it short circuits to use default. Though we'll see an even better way for defaults later with deaths.
Interesting. Okay. And it's also used for conditional execution like is allowed and perform action. Only calls perform action if is allowed is true.
Exactly. Very concise.
Cool. Now let's switch gears a bit. Bitwise operators. These sound intense.
Hey, yeah, they're a bit more niche. They operate on numbers at the binary level, like manipulating the individual ones and 0.
So not something you'd use every day in, say, building a web form.
Probably not. But they're incredibly powerful for certain things. Performance-critical operations, graphics, working with flags or permission stores numbers. They let you do very efficient, low-level manipulations.
And the main ones are and bitwise AND, bitwise OR, bitwise XOR.
Right, and also bitwise not T, left shift, right shift.
Can we see a quick example just to get a feel for it?
Sure, let's take a 5 and B looks 3. In binary, 5 is 101 and 3 is 011.
Okay.
If you do A and B, bitwise A and D, you compare each bit position. It's only 1 if both bits are 1. So 101 and 011 gives you 001, which is the number 1.
Because only the last bit is 1 in both numbers.
Exactly. If you do A, bitwise OR, it's 1 if either bit is 1. So 101, 011 gives 111, which is 7.
I see. And AB, bitwise XOR.
XOR is 1 if the bits are different. So 101, 011 gives 110, which is 6.
Okay, I can see how that would be useful for flipping specific bits or checking flags. Is there a common pitfall here?
The main thing that can seem weird is how they handle negative numbers, because computers use a system called 2's complement for that. It can lead to unexpected results if you're not familiar with binary representation, but again, it's more advanced stuff.
Got it. A specialized tool. Let's move on to special operators. These seem like handy utilities.
They definitely are. First up is the conditional operator, often called the ternary operator.
Ah, yes, the question mark and colon one. Colon value, if true, value if false.
That's the one. It's basically a super concise if-else statement that fits on one line, primarily used for assignments.
Like let status AG 18, adult minor. Really clean for simple cases like that.
Exactly. It's great for simple choices, but you wouldn't want to nest them or put complex logic in there. It becomes unreadable fast. And if-else is better then.
Good point. Readability first. What's next?
The type of operator. This one's straightforward. It tells you the data type of whatever you give it. as a string.
So type of hello gives string,
Yep. Type of 42 gives number.
and type of true gives Boolean?
Correct. It's useful for checks. And the guide mentioned a best practice for checking undefined. Is type of variable undefined? It's safer than just variable undefined if the variable might not even be declared, preventing an error.
Ah, that's a good tip. Okay, what else in special operators?
A relatively newer but very useful one, the nullish coalescing operator, thing of the day. Double question mark.
Right, you mentioned this earlier when we talked about defaults with eval. What's the key difference again?
The key is nullish. The operator only looks for null or undefined on the left side. If it finds either of those, it returns the value on the right.
Okay, and logical OR.
Looks for any falsy value on the left. That includes null and undefined, but also 0, empty string, and false.
Ah, so CC is more specific. It lets 0 or bool pass through if there are valid values you want to keep.
Exactly. If you have let user count 0, and you do let display count user count 10, display count becomes 10 because 0 is falsy.
Which might be wrong if 0 is a valid count.
Right. But if you do let display count user count 10, display count stays 0 because 0 is not null or undefined. It's perfect for defaults when 0 or empty strings are legitimate values.
That is a really useful distinction. Okay, so we have all these operators, but they don't just run randomly, do they? There's an order.
Absolutely not. That's where operator precedence and associativity come in. It's crucial for understanding how complex expressions get evaluated.
Like PEMDAS or BUDMAS from school math, but for code.
Pretty much, yeah. Parentheses. Always when they have the highest precedence, letting you force the order you want.
Always good practice to use parentheses if you're unsure, or just for clarity, right?
Definitely. After parentheses, you generally have unary operators like plus AA, then multiplication and division plus A% before addition and subtraction plus A.
Okay.
Then come the relational comparisons followed by equality.
Lower down the list.
Yep. And near the bottom are the logical operators. AND comes before OR, and right at the very end are the assignment operators, etc. They usually happen last.
So if I write let result is 5 plus 3, 2.
Multiplication has higher precedence than addition plus 0. So it does 3, 2 first, which is 6, then 5 plus 6, giving you 11.
Not 16. If I wanted 16, I'd need parentheses. Let corrected, it keeps 5 plus 3, 2.
Exactly. The parentheses force the addition to happen first. Understanding precedence avoids a lot of unexpected bugs.
Makes total sense. So pulling this together, what are the top best practices the guide recommends when using these operators?
Okay, number 1, we've hit it a few times, but it's worth repeating. Use strict equality over loose equality. Seriously, just do it.
Avoids those weird type coercion bugs. Makes code predictable. Got it.
Second, leverage short-circuit evaluation. We saw how Annonin can make conditional logic really concise.
Like the user in user is active in display dashboard example instead of nested ifs.
Exactly, it's elegant. And third, use compound assignment operators like plus when you're updating a variable based on its current value.
Counter plus 1 is better than counter plus 1.
Yeah.
More concise. And counter plus plus for simple increments is even better.
Precisely. These little things add up to cleaner, more maintainable code.
But even with best practices, JavaScript has quirks. Let's talk common pitfalls. First on the list, that type coercion confusion again.
Yeah, it bites in multiple ways we saw versus R, but it also affects arithmetic operators, especially plus fear. Remember, console.log 5.3 gives you 2.
Right, because coerces the string 5 to a number.
But then console.log 5 plus 3 gives you 53.
Because plus sees a string and decides to do concatenation instead of addition. It's inconsistent if you're not expecting it.
Highly inconsistent seeming. The solution: be explicit. If you want math, make sure you have numbers. Use number to convert. Number 3. If you want concatenation, make sure you have strings. Use string. 5 plus string 3. Don't rely on implicit coercion.
Clear intention. Makes sense. What's another big pitfall?
Floating point precision. This isn't strictly a JavaScript operator issue, but it affects arithmetic constantly.
The infamous 0.1 plus 0.2 problem.
That's the one. It doesn't quite equal 0.3. You get 0.3000000000000000004 because of how computers store decimal numbers in binary. It's a limitation inherent in most programming languages.
So what do you do about it? Especially if you're dealing with, say, money.
Well, for display purposes, you can often use methods like to fix 2 to round to 2 decimal places or to precision. But for calculations, especially financial ones where accuracy is critical, you really should use a dedicated library like decimal.js or similar that handles these precision issues properly. Don't try to manage financial math with standard floats if you can avoid it. Just be aware the limitation exists.
Good heads up. Okay, let's see these operators in action. Can we look at some real-world applications?
Absolutely. Think about an e-commerce price calculator. You're
Right.
building a function, maybe calculate total.
Right.
Inside, you'd use for subtotal, price quantity. Then maybe N for discount amount, subtotal, discount percent 100. Then for discounted price, subtotal, discount amount. Then again for tax, discounted price, tax rate. And finally, plus for the final total, discounted price plus tax. It's just arithmetic and assignment operators driving the whole calculation.
Yeah, you can really see them as the workhorses there. What about something less number-heavy, like user authentication logic?
Perfect place for logical operators. Imagine a function can access resource, user.
Right.
It might return something like user and user.has authenticated, user.role admin, user.has permission.
Wow, okay, break that down.
User and user.s authenticated uses NNA first, make sure the user object even exists and that they are logged in, short circuits if not.
Right.
Then another NN connects to the permission check. Inside the parentheses, you have user.role admin user.has permission. That uses for a strict role check. And OR, they get access if they are either an admin or they have the specific edit permission.
That's incredibly expressive. You can build complex rules really clearly with N and mirror.
Exactly. And one more, data validation. Think validating an email address in a form.
Happens all the time.
A validate email function would use several operators implicitly or explicitly. You'd check type of email, using type. You check email.length 0 using hash. You might check email.includes using methods that return booleans combined with NN.
So you're using comparison and logical operators to enforce the rules for what makes a valid email format.
Precisely. They're everywhere once you start looking.
Wow. Okay, we have covered a lot of ground. From the basic math with arithmetic operators to efficiently updating values with assignment operators.
To making decisions with comparison operators, especially that crucial versus distinction.
And combining those decisions powerfully with logical operators, including that clever short-circuiting behavior.
We also touched on the lower-level bitwise operators, the handy special ones like the ternary and type of, and that really useful nullish coalescing bell.
Plus, understanding the order of operations with precedence, sticking to best practices like strict equality, and watching out for pitfalls like type coercion and floating point issues.
It really covers the spectrum of how JavaScript performs actions and makes choices.
So the big so what, for everyone listening, why does mastering these details actually matter?
Well, it's really about moving beyond just knowing the syntax. It's about understanding the language JavaScript uses to get things done. When you grasp how these operators work, why is safer, how short-circuiting functions, you start writing code that isn't just functional, but genuinely more robust, efficient, and predictable.
You're basically speaking JavaScript more fluently, understanding its nuances.
Exactly. You avoid common bugs, you write clearer logic, and you can leverage the language's features more effectively. It empowers you to build better applications.
These operators, they seem so simple individually, but they really are the hidden gears, aren't they? Driving pretty much every interactive thing we see online.
They absolutely are. The fundamental actions and decisions all boil down to these symbols.
So here's something to think about. Now that you've maybe got a deeper appreciation for these fundamental JavaScript operators, how might paying attention to these kinds of details, the precedence, the type handling, the subtle differences, change how you approach solving problems or even hunting down bugs, not just in JavaScript, but maybe in other languages too? Because often these core concepts, they pop up everywhere, don't they?